Good morning. So we are discussing the PLC programming, and we have seen few simple programs in last session. In today's session, we'll be going to discuss about some special functions that are used in PLC. So the first function is the PLC timer function. So what is basically PLC timer? These are the special operands of a PLC which represents the time delay. It represents the time delay uh, in the relay logic system. And these timer functions, these are the timer functions which are mounted on the part of CPU. So timer functions are mounted part of CPU of PLC. Okay, and the number that are mounted, the number of timer functions that are mounted on the part of CPU that are vary from your manufacturer to manufacturer. With the help of this timer function, it is possible to attain time delays within the range of few milliseconds to few hours. So what is the use of this? To attain the time delays. Attain the time delays. I'll explain what is this time delays. So first you should remember that these timer functions are used to attain the time delays that may range from a few milliseconds to few hours, and these are the parts which are mounted on the CPU of PLC. There are two types of timers. First is on delay timer. What is on delay timer? Now, when your input signal becomes on and the output signals become on within certain delay. Let me put over here. Input signal is on, and because of that the output signal becomes on with certain delay. With certain delay. That is what we call it as a on delay timer. It should be noted that once the input signal become off, the output signal become off at the particular instant. When your input signal is off, the output signal becomes off at the similar instant. Similar instant. So, what is basically this on delay timer? If your input becomes on and off with a less than a time delay, there is no change within the output and it remains off. For example, if you have to turn on the motor, turn on the pump, let us say, okay, so you will give the you will make the switch to be on. So your switch will be on to turn on the pump, but the pump will not start immediately when your signal when your switch is on, because this pump requires priming. if this pump require priming, then it will take some finite amount of time to complete this priming process. So what happens because of this, your output, that is your turning on of the pump, is delayed by certain amount of time. Let us say you push the make the switch on at the first second, so that is your input on, and after 5 seconds, after 5 seconds or 10 seconds, your pump will be on. So what happens within this 5 second? Your priming takes place. Priming of the pump takes place. Okay. So when your input is on, your output signal becomes on with a certain delay. So here we have a 5 seconds delay. Okay, that is what we call it as a on delay timer. So your output is become true by some delayed time. That is what we call it as a on delay timer. The next type is off delay timer. Off delay timer. Now what is off delay timer? When your input signal is on, it becomes on, the output signal becomes on at identical time. At identical time. But once your input signal is off, when your input signal is off, the output signal becomes off, it becomes off with certain delay, with certain delay. That is what we call as a off delay timer. For example, uh, you turn on the engine. This is your what we can say, output required. So what is input for that? You push the start button switch. Start button. Okay. When you push the start button, immediately your engine is turned on. Okay. But when you push the stop button, when you push the stop button, push the stop button, it is seen that your engine, or what we can say, the turbocharger or intercooler part of the engine, that remain on remain on for certain duration of time, because it requires some function, it requires some circulation of the fluid into that, so it remain on for 5 seconds, let us say. So although your input is off, but you are still getting your output for a particular delayed amount of time. That is what we call it as a off delay timer. That is called as off delay timer. So input on, output becomes on at identical time, but input, when your input becomes off, the output becomes off with a certain time delay. That is what we call it as a off delay timer. On the other hand, if you give the input signal to be on, the output is on with a certain delay, that is called on delay timer. When we keep the input signal to off, the output become off at the similar instant. So that is the difference between your on delay timer and out delay timer. Then how to represent the timers on the PLC ladder diagram. Let us say this is on delay timer, it is represented by T on. and it is represented by this block. So here T on means timer on delay. So we are using on delay timer. First part is your timer. Okay. So I have said that we have seen that the timers are mounted on the CPU of the PLC. So that what timer the programmer needs to select is identified with the help of this number T4.0. Okay. Then we have a next time base. So time base gives us the interval with which your timer is ticking. Like once we make the timer on, it will first show point 0.1, then point 0.2, then point 0.3. Likewise, it go on ticking. So it's an interval between which with which the your timer is going to tick it. Then we have a preset value. We have a preset value. Let us say it is 500. So what does it mean? If it is a on delay timer, so your input I am giving to the first second, and when I supply the input, your timer starts timing. Fine. And it will increase the time base by 0.01, 0.02, 0.03, and it will reach up to the preset value. It will reach up to the preset value of 500 seconds, and after this preset value is reached, your output becomes on. Okay. Also, we have this one is called as accumulated value. So, accumulated value gives us the what at what position the timer is right now. Let us say it is in point 0.1, point 0.2, point 0.3, point 0.4. So, these values comes over here. And once your accumulated value is equal to preset value, your on delay timer will be on. We have two beats over here. First beat is enable beat. So it's a kind of internal relay. So it is a kind of internal relay which gives the signals to the further processing. So enable beat is the beat which activated once your timer is on. Okay. Your timer, once it starts ticking up, timing, the enable beat is on. That means at the first second when we push the switch, your enable beat will be on. Then the timer starts timing, then it goes to up to accumulated value, goes to the preset value, that is of 500 seconds. When this accumulated value is equal to the preset value, your done bit will be activated and it gives the signal to the some further processor. Okay, so that is how your uh, what I can say the timer function works. This is for on delay timer. We have timer number, time base, preset value, accumulated value, enable bit, and done bit. Second timer, we have T off. So we have it is represented by T off. The same thing we are having over here. Only the difference is timer of delay. So we have timer number, we have time base, we have preset value, we have accumulated value, and we have enable bit, and we have done bit. Now what is when these bits are activated? When you push the switch or input is on, then your enable bit is activated. Enable bit is activated, and when your 1 second. enable bit is activated. Okay, and when that means your input is on, enable bit is activated, and output is on. So timer starts timing, your accumulated value will reach to up to nearer to the preset value, and when your accumulated value is equal to preset value, your input, or not that much, when your input is off, at that point of time also your timer starts timing, and after the accumulated value is equal to preset value, your done bit is activated, and when your done bit is activated, your output is off. Okay, I'll once again repeat it. It's little bit confusing, but once we go for the program, you will get the clear-cut idea about this. Input is on for off delay timer, enable bit is activated, output is on. When your input is off, the timer starts timing, and after that, your accumulated value starts increase. When it is equal to preset value, your done bit is activated and output is off. So after input is off, your timer starts, or the timer starts accumulating the value, then your done bit is activated, and after that your output is off. So output is delayed by certain amount of time. The cutoff of output is delayed by certain amount of time, that is done with the help of delay timer. Now we will have one simple program, which is a very practical program of traffic lights, that we traffic light signals that we see on the various squares. So that program we will discuss with the help of this on delay timer. The on delay timers are used in that particular application. So there we will be using three on delay timers. Okay. Now what are the condition? We want red light to be on for 31 seconds. We want red light to be on for 31 seconds. Then we want green light to be on for 28 seconds, and we want the amber light on for let us say 6 seconds. Okay, so what we'll assign? Some switches like in the previous program. So we assign P1 for start button. We'll give the T1 as red light times, one time delay timer. Second time delay timer will give for green light, and third on delay timer will give for the amber light. Now again note that on delay timer starts when your input is on, and after completion of the preset time, enable bit is off, and done bit is on of the times. Now let us see the program. It's a very interesting program. So these are the power rails. Okay, we will put over here a start button, that is P1, and we put a internal relay switch of done bit of T3. So it is done bit internal relay associated with the done bit of T3. So again I am telling, internal relays are the memory locations which are saved at the memory of the controller, and their activation and deactivation depends on the condition, that is true or false, at the last signal from the last signal. So here I'll be putting the T1 timer red light times. Okay, so here I'll have the time base of 0.01, preset value of 3100, that means 31 second, and accumulated value equal to 0. And over here I have enable bit and done bit. This is my first run. Then I'll write done of T1, and over here I'll put another timer, that is T2 for green light. Here also I have time base of 0.1 seconds. Here my preset value is 2800 and accumulated value which is varying. Then I have over here enable bit and here done bit. Then I'll put an internal relay associated with the done bit of T2, that is the previous timer, and here I'll be putting the third timer T3, that is for amber light. Here also I'm using the same time base, but the preset value over here is let us say how much we took, 6. So it is of 6 seconds, and accumulated value it is varying. Over here I am having enable bit and done bit. So these are the three timers I have put over here. Then here I'll be putting here I'll be putting enable bit internal relay associated with the enable bit of T1, and along with that I have done of T1, and this is the output, that is my red light. Okay, so this is done. After that I have put over here enable bit of T2 and done bit of T2, done of T2, and here I have having green light. And third, you can guess now, enable of T3 and done of T3. So here I am having amber light. So it's very interesting program. Let us see one by one what happens. So this is my rung 1, this is rung 2, rung 3, rung 4, 5 and 6. Now see carefully what are the conditions are there. I push the press button, condition 1. I push this P1 switch, which is a start button. Okay, what happens? The signal flows like this. I'll change the color so that uh, you'll get the idea. Yeah. So I push this switch, so the signal goes like this. The done bit of T3 is off. That means it is normally closed switch. It will not activate it. So that's why it is in close contact. Okay, we haven't done anything with done bit of T3. So that's why the signal will continue to flow over here, and it will activate this T1 timer. Okay, this will activate this T1 timer. And as soon as this T1 timer is activated, your enable bit is activated for 31 seconds. Okay, when this enable bit is activated, your green light will be on. Okay, your green light will be on. It starts, let us see, it is when your enable bit is activated. As soon as you get some input, your timer, your red light is on. Okay, and once your accumulated value is equal to preset value, then your done bit will be activated. So what happens over here, as soon as you get the signal, that is input, your enable is activated. Once your enable is activated, your accumulated value will starts accumulating. Fine. At the same time, your red light is on once we get the input. When your accumulated value equal to preset value, that is of 36 seconds, your done bit will get activated. Okay. Once this done bit will get activated, the sequence goes to rung 2. Now this is an internal relay associated with your done bit of T1. So this is normally open type of contact. When we activate it, it will get closed and your signal goes over here. Fine. So once your signal goes to this one, your timer starts timing. So we will see this simultaneously. Okay, when we go for the rung 4, 5 and 6. Fine. So when now you have rung 1. Rung 1 is understood, enable bit is activated, red light is on, and accumulated value is equal to preset value. So go to rung 5. So enable bit of T1 is on over here. So here also we'll get this red light on. So this rung 1 is connected to your rung 4. Okay, you can put this rung 4 after this rung 1 also, but for the sake of simplicity, I have put over here. When enable bit is on, this is an internal relay associated with the enable bit. That means these contacts are closed. We haven't gone to done bit right now. So red light is on. When your enable bit accumulated value is equal to preset value, done bit is activated, and when this done bit is activated after 36 seconds, this contact will get break and your red light will be off. Now here also your done bit will get activated, internal relay is activated, your timer 2 starts and it get the input. Now as soon as this timer 2 get input, your enable bit is activated. Okay, now go to rung 5. The enable bit of T2 is activated. That means the signal is going like this and your green light is on. At the same time, your timer is ticking when your accumulated value is equal to preset value, that is equal to 28 second. After 28 second, your done bit will be activated. Done bit is activated. As soon as your done bit will activate, this signal breaks, this contact breaks, this is activated. That means your green light will be off, and at the same time this done bit of T2 will activate and this will get closed. So for same internal relay we have two types of contact, one is closed and one is open. So you need not to bother about which type of contact we are using, we are just sticking to our basics, that once you get input, if there is a normally closed contact like this, it will get activated and the circuit is break. When you get input and it is normally open type of contact, so your circuit is completed. circuit is completed. Also, you should remember that these are the internal relays are the memory locations associated with that particular switch. Okay, particular bit over here, enable bit, done bit, or the switches that we are using. And as soon as they get the particular conditions, there is a simultaneous or sequential on and off as soon as they get the inputs and outputs. So coming back, now your green light is on, the green light is off, and your done bit of T2 is activated. When this done bit of T2 is activated, the signal input goes to the timer T3, so that will activate the enable bit of T3. Okay, when this T3 is on, activated, your amber light is on, your accumulator starts accumulating the value. When this value is equal to preset value, that is of 6 seconds, the done bit will get activated. Okay, so here when input is on, enable bit is on, so you will get the signal like this. We haven't, the done bit is yet to activated, so signal goes to amber light, it will remain on for 6 seconds. As soon as accumulated value is equal to preset value, your done bit is equal, done bit is on. Done bit is on, that means this normally closed contact will open, and when this contact is open, circuit is broken and amber light is on. Okay, so that is how, once at the first instant your input, when you give the input, your red light is on for 36 seconds. When you go give the input, after the time lapse of 36 seconds, again you get the input for the green light, which will be on for 28 seconds, and after that you will get the input for the T3, that will your output will be activated for 6 seconds. So that is how your input and output relationship and the that is happen with the on delay timer. So to sum up this, what I want to say, T on delay timer, it will delay the output, and T off delay timer, it will remain the output for a particular delay. Now let us see one more program related to your on delay timer. Let me once again share the screen. So this is example of on delay timer again. Welcome back. In this session, we'll be going to discuss a few more ladder logic programs, which may be based on timers. Okay. So to start with, this one is a typical example. We'll see over here that what is the condition given for this example. So motor, there are three motors, M1, M2 and M3. We are having two push buttons, push button 1 to start the motor and push button 2 to stop the motor. So the conditions that we need to achieve are motor M1 starts immediately after your button will push, start button will be pushed. After 10 seconds, motor 2 will start, and after 5 seconds, motor 3 will start. So with the predefined time elapse, your motors, sequence of motors will be going to happen. We are using two timers over here, T1 and T2, both are on delay timers. Also, we are using some control relays and some internal relays associated with motor M1, M2 and M3. So the rung number 1, if we talk of, so here we have installed push button 1, which is a start button, and push button 2, which is a stop button. And also R1, it is a control relay associated with motor M1. Also, we have various internal relays, that is R1 internal relay associated with this control relay. So you can easily guess that this is your latch circuit. So once you give initiation, your output remains energized although the input ceases. Okay, so here it is a latch circuit. So once you press the push button 1, your R1 control relay R1 will remain energized so that the rung 1 logic is completed. Here in the second rung, since R1 is energized, this open type of contact is get closed, and it will goes directly to motor M1 to start the motor number 1. Okay, this arrangement we have given for what we can say termination of the circuit, that I'll explain it later. Again, in the third rung, this is R1, that is internal relay, push button 2 internal relay, and timer 1. Please note that here I am saying that R1 over here, R1 over here, and R1 over here. These are the memory locations and the contacts associated with these memory locations. So once I say that relay control relay 1 is energized, that means this internal relay associated with control relay is also energized. That means normally open type of contact is closed, and whenever I'll find the internal relay associated with control relay, that all those internal relays will be remain, it should be remain closed or follows the particular the same function or same logic. So here this R1 is close contact, and it will energize the timer T1. Once this timer is energized, as explained earlier, the enable bit enables, and the value starts accumulating. Okay, so it will starts counting 1 2 3 4 5. As soon as the accumulated value equal to preset value, your done bit will be activated. Okay, once this done bit is activated or energized, this is an internal relay associated with the done bit of timer T1. That means this normally open type of contact will get closed, and the signal passes like this through PB2, and this control relay, that is R2, will get activated. Okay, after the activation of done bit. As soon as this control relay, which is associated with motor 2, that will get energized, all the internal relays associated with control relay R2 will get energized. Okay, here you can see that second in the next subsequent rung, this is the R2, which is internal relay associated with this control relay, which is normally open. After the energization or activation of control relay, all the relays will be get energized, and this normally open will be now normally closed, and your motor M2 will start. Once this motor M2 will start, the signal flows to the next rung. As I said, R2 is activated. That means open type of contact is closed. So it will give initiation to timer number T2. Now at 0th instant, M2 is start, and it is given the initiation to timer T2. That means its enable bit is activated. Once this enable bit is activated, the timer starts timing, and the value will starts accumulating. That will continue until 5 seconds are lapsed. Once this accumulated value equal to preset value, the done bit of timer T2 will get energized or activated. Also, the internal relay associated with the done bit of timer T2 will get activated, and this open contact will get closed, and it initiates or energizes the third relay, that is R3, which is associated with motor 3. As soon as R3 relay is energized, this all the internal relays associated with R3, that is control relay R3, will get activated, and the signal flows will like this, and motor M3 will start. So these conditions are achieved. As soon as I push PB1, it will activate, or motor M1 will start. After the starting of the motor M1, the initiation is given to through the control relays and in internal relays to timer T1, and the timer starts timing. After 10 seconds, your control relay R2 is activated, which is associated with motor 2, and motor 2 will start. After once the motor M2 starts, at the same time, the initiation or the signal is given to timer T2, which starts timing for the next 5 seconds. And once that 5 seconds time is over, your control relay R3 is activated, which is associated with motor M3, and after 5 seconds, motor M3 will start. Now, the condition is when we press the push button 2, all the motors must be stopped. So that's why for each subsequent trunks we have provided the internal relays associated with the push button stop button. So here once we press this push button 2, this normally close contact will get some true input, that is one input, and this contact will get break. Once this contact is broken, all the internal relays will be happening or receiving the initiation, and the related contacts will be get broken, and at the same time the motor will stop. For example, if I give initiation over here, that means this PB2, this normally closed contact will get open, and let us say this rung. So here this is PB2, that is internal relay associated with this stop switch. This will get open and your M2 motor will stop. Over here, same internal relay will get initiated, motor M1 will stop, and here also this internal relay will get initiated, and motor M3 will stop. So this is how your on delay timers are used for the sequential starting of the motor. Okay, so this is one example. Let us see one example on off delay timer. So what is off delay timer? When your input is on, the output is on at the same time, and when your input is off, at that point of time also, after few seconds your output is on. So let me first mark the condition: input on, same time output on. Then if input is off, your output is still on, and after some time delay your output is off. That is what we call it as a off delay timer. So output off is delayed by particular amount of time. So that is what we call it as a off delay timer. Now let us see one example. We have one oven which is heated with the help of some heating element. We have one fan also. So the function of the fan is to distribute the heat inside your heater, and also to the oven cool the oven after use. Okay, so it first it distribute the heat inside the oven, and after that when the work has been done, it will cool the oven. Now we'll say that when heating element, when we provide input, the heating element and fan turns on. Okay, for the circulation of the air and to spread the heat. When we push the button, the heating element will be off, and after that the off delay timers starts counting down. Okay, and when the timer is done, your fan will turn off. Now for that, I'll be using P1 as a start button. Also, I'm having P2 as stop button, and let us say M I'll be using as a control relay. T1 is I'm using as a timer, H for heater, and F for fan. So let me draw the ladder diagram for these conditions. So I'm writing, I'm drawing a latch circuit over here, P1, then P2, this is start, this is stop, then I'll put a control relay over here, M, and from this I'll put one M, which is an internal relay associated with this control relay, and the signal is like this. This is my run 1. Then this M internal relay I am connecting to the on delay timers over here, sorry, not on delay, off delay timer. So here I am having timer, that is T1, time base, that is of let us say 1 second, then preset value of 20 seconds, and accumulated value. Also I am having enable beat over here and done beat over here. Okay, I am connecting again this internal relay with my heater. Fine, and I am connecting this uh, done bit of T1, which is again an internal relay associated with done bit of T1 to the fan. Let us see the logic. I press the push button switch. I press the push button, momentary push button switch, so the circuit get completes. This control relay is activated. Once this control relay is activated, whatever the internal relays associated with this is also activated. So this internal relay is activated, so the signal starts flowing like this, and this M is on. Now again this M is internal relay associated with this control relay, so this is normally open, so circuit get closed because of the true input. Fine, and the timer is also starting. Here also my internal relay is activated and heater is on. Okay, now at the same time, when I push this, what I can say, this push button switch. Okay, so what happens because of this push button switch? Your internal relay will get disconnected. Internal relay will get disconnected, and your timer starts timing. Okay, once your accumulated time is equal to the preset time, your done bit will get activated. Okay, and when your done bit will get activated, your fan turns off. So once I push this push button switch, when I push the stop button, what happens after this? Heater element start, heater element is stop, but your fan remains on, and after 5 seconds, when your accumulated time equal to preset time, that is 20 second, let us say, your done bit is activated, and once the done bit is activated, your fan turns off. So after your input is off, still your output remains on for a particular duration of time, and after that you will get your what I can say, the output that will remain, that it is delayed, the output uh, is delayed for a particular duration of the time. That is what we call it as a on delay timer. Let us see one more thing, that is your counter function. Yeah, so we have one more function called as counter function, similar to that of timers.
Welcome back. In this
Let us
session,
watch
we'll
this.
be going to discuss the PLC counter function. So previously, we had discussed about timer functions, which are used for the delay of the input or the delay of the output, or what we can say it as performing some functions based on the timer function. Now, here we'll be going to discuss the counter functions. So counter counts the input changes from false to true. In one scan, input is false. In next scan, input is true. No further count takes place until the input goes to false again. Counter has preset number of counts. After the accumulating the preset number of counts, counter becomes true. And after becoming true, it activates some other part of the ladder diagram. For example, it is used for counting the milk bottles, and if you have to pack it in the box of 10 bottles, then it will count 10 bottles and then it will stop. So here, similar to that of timers, we are having enable and done bit. So this is switch, input switch. Once we press this switch, this counter starts counting and enable bit is activated. The preset value is 50 and the accumulator starts accumulating the values like 1, 2, 3, 4. Once this 50 is reached, count of 50 is reached, that is accumulator value equal to preset value, the done bit of the counter will get activated and it shows some output, or let us say it glows some light, or it blows some buzzer, so that the operator comes to know that the particular count has been reached. Now if we want to reset it, if you want to reset it, we are having reset switch also. So if you press that reset switch, it will be resetting the counter 1 over here. once you press the reset switch, your accumulator value will be 0, which was 50 in the previous count. So preset stands for counter gets into preset value, makes the done bit to be true, and accumulator it holds the value of the current count. So it is counter functions are used for counting the number of operations.
Okay, so that's all for today's session for now. You can post your attendance in the chat box and you can log off the session. Thank you.